Okay, so we're going to talk about aromatic compounds. I guess this is also where I threw out like your exam is going to be on Monday. Uh, hey, you are because of this like weird start to the semester. This is going to be the like least amount of material exam one has ever had in organic two. So I'll get you back later. Like that second exam is going to be like awesome, but the first exam, this is going to be a cakewalk. All right. So in the olden times, we kind of divided organic compounds into like these two broad groups. So, right. So we had aliphatic compounds, and aliphatic just means fat-like. Right. So if you think about a fatty acid, right, you have the glycerin like head, and then you have the long straight chain of just carbons that come off of that. So aliphatic was just things that were long straight chains, right? And then we had aromatic compounds, and these are benzene like. Right? These are very stable. We'll talk about why here in a bit. And benzene is our generic aromatic compound that we use for aromatics in organic 1. Right? So benzene, switch slides here, is a cyclohexane that has 3 double bonds in it. And so compounds that shared similar characteristics to just the stock basic benzene are called aromatic. The first thing we're going to do is we're going to learn how you name different aromatic compounds. And then we're going to circle back and talk about um, the properties and why benzene compounds are very stable. But we're going to start on, I've got to unlearn you some naming and then learn you some naming. Remember when we started naming? I was like, we don't just like give things random names. We use a systematic way of naming things. That way you can name anything. Well, for aromatic compounds, I'm assuming again a bunch of old white guys got together and said, let's just call them random things. And so you have to learn all the names, all the random names for these compounds so you can actually name aromatic compounds. Right? So I mean, again, there's a committee from IUPAC, the people in charge of naming stuff, that meet to come up with names. So if you want to get on the IUPAC committee and then change the names, by all means, I will change the slide that I'm looking at right now for future generations. Right. So, right, stock one is benzene. Right. Easy enough. If I put a methyl group on benzene, you don't get methylbenzene. Oh, no, 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 no. You get toluene. So, fun fact, benzene is very, 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 very bad for you. Benzene gives you liver cancer. They figured this out because the two most different groups of people in the world had really high rates of liver cancer, and the thing that tied them together was benzene. So you have nerdy chemists like me, and then manly men who do manly things like repave roads, right? Both had, not me, both had really high rates of liver cancer because the thing that both of them did at the end of their day was, well, I'm going home, gonna wash my hands in benzene before I leave. Because the thought in the organic lab was, well, benzene dissolves a bunch of stuff. It's not reactive, so it'll get anything that's on my hand off. And benzene apparently also dissolves road tar really well. So I got all this road tar stuck to my hand after a hard day of working in the sun, being manly, right? I'm going to wash my hands off with some benzene. Well, benzene gets oxidized in your liver. It gets an oxygen put on either side of the benzene, and then that molecule can oxidize and rips hydrogens off of DNA, and then causes your DNA to cross-link, leads to mutations and cancer. But if you put a methyl group on it and you make it toluene, it doesn't do that anymore. It's way better for you. Again, not doing shots of either, but toluene is better for you because of the methyl group. Again, the more you know. You have an NH2, or just like any like nitrogen. It could be two methyl groups. It could be a methyl and a hydrogen. Just a nitrogen coming off of your benzene ring. Oops. That is aniline. If you have a methoxy, and it only applies to methoxy, you have anisole. Again, living comfortably beneath the rules. I did not make this up. 20 years ago, someone looked at me and said, you need to know these. I was like, all right, cool. And now, 20 years later, I'm looking at you and saying, you need to know these. You would challenge the system, exactly. Exactly. This is one you kind of know. Styrene. So, have you ever heard of polystyrene? Like various foams and whatnot? That's a bunch of styrene stuck together. So this is the building block of a bunch of foams and plastics and stuff. If you have a methyl ketone coming off of your benzene ring, that is acetophenone. So when I was in grad school, it was the early 2000s, and everyone knew a techno DJ, and I lived with a techno DJ. Now I got to specify, this isn't like current DJs where they just have like a MIDI board, they just like hit some like buttons and do this. Right? No, this was like he would like get physical records sent from England and like had multiple turntables. And he was like, "Yo, man, I'm DJ Trinity." I'm like, "Dude, there's like 85 DJ Trinities. Like, that's not hard. Like, what are you doing?" I was like, "Your name's Ben." He's like, "Yeah." I said, "There's a molecule called benzophenone. You should just be DJ benzophenone." He was not down. He's like, I'd rather be the 4 millionth DJ Trinity than the first DJ benzophenone." It's like, damn it, dude. Yeah, it sounds like a total DJ name. If Skrillex gets to be a DJ name, benzophenone gets to be a DJ name. He's like, I'm DJ Trinity. I'm like, come on, man. What, you watched The Matrix and we're like, her. That's what I'm going to do. That's my DJ name. What her name is. All right.
From Zoom, a student said, "Well, that's what my parents did."
Your parents, you're named after Trinity from the Matrix? Okay, that's pretty cool. Can you like jump and then slow mo and kick someone in the face? Absolutely not. I mean, you had your Halloween costume lined up at least till you were 7. They just like put you in teeny tiny black leather and just like took you around. This is phenol with an OH on your benzene ring. Phenol, just about as bad for you as benzene, because benzene, when it goes to your liver, first gets turned into phenol. That is step one to liver cancer is phenol, right? We're gonna pretend like we have enough room for this next one, or we're gonna switch pages. We're gonna switch pages maybe. If you have a carboxylic acid, this is benzoic acid. Matrix 4 is coming out soon. I like to pretend there's only like the Matrix, and then there was nothing, and then it will be the Matrix 4. 2 and 3 were a little rough, or a lot rough, right? And then we have xylene. And xylene comes in 3 flavors. I'm sure they're all awful, right? Where the 2 methyl groups are side by side, where there's 1 carbon between the 2 methyl groups, and where there's 2 carbons between the 2 methyl groups. And we are going to go over how you differentiate those in naming here in a second. But for you to be able to name aromatic compounds, you need to know all of these common names, right? All of these plus benzoic acid on the other page, right? You need to have these like in your pocket, because if you don't, you really can't name your structures. So you need to know all of these. I foresee this exam having a lot of naming on it because it's not going to have a lot of reactions because we're not going to get to all the aromatic reactions. And I can only ask Diaz-Alder questions so many different ways before I start repeating myself. Now, that might be 10 different ways, but I start to run out of things. All right, so the easy ones are monosubstituted benzenes. So when you have monosubstituted benzenes, the suffix is, brace yourself, benzene. So if you have a benzene ring that has a substituent on it that is not one of the 8 that I gave you that gives it a special name, you say what the substituent is, and then you put benzene at the end. Super easy. So you look at it, and you're like, okay, a bromine on a compound is bromo. It's attached to a benzene, bromobenzene. People are in here like shrugging and throwing up their hands like they're insulted that this is the way this works. Take your wins where you can get them, people.
The question was, why do we have the common names at all?
I don't know. I think a lot of the common names come from something that was discovered 150 years ago and we didn't know what it was, and it was characterized some way and it got some name because of how it smelled or what it looked like. And then once we figured out what it actually was, it was so the common name was so ingrained that they were like, we're in too deep. We're not going to change it. Now, not realizing that they could have changed it 100 years ago and no one would remember that it was called anisole in 1920, in 2020 or 2021, right? It would have been fine. But they were like, we're in too deep. Now we know what it is. We always called it anisole. I don't want to change. Do you? I don't want to change either, man. Okay, cool. Anisole it is till we die. And then they died, and we just kept calling it anisole. What's this? Hmm? What's an NO2 group called? Nitro? Nitrobenzene. Yeah, that works. Ethoxybenzene. So these, super easy, right? You just have to identify whatever the substituent is and then say it's on a benzene. Done. All right. Now here's where it gets weird. All right, get ready. Right, so disubstituted benzenes. What do we use when we have to say where groups are like on a chain? Right? We use numbers, right? We're like, oh, this is 2,4-dibromopentane. Silly children. In disubstituted benzene, we use letters to tell us where groups are. And this is only for disubstituted benzenes. When we go to try substituted benzenes and above, we go back to numbers. But in just this one little spot, we're like, yo, letters. All right. So there are three different like substitution patterns that we have to be able to identify on a disubstituted benzene. And we'll use xylene as our example here. Right? When your two groups are on adjacent carbons, those two groups are ortho. So this would be ortho xylene. But ortho is a lot of letters to write. That's like 5 whole letters. That's a lot. So how about we just call it O-xylene? So when your two groups are on adjacent carbons on the benzene ring, they are ortho. Or you just put O. When there's one carbon in between, they're meta. So this is metaxylene. Now, 4 letters is less than 5 letters, but it's still a lot of letters. So let's just call it M. So this is M-xylene, metaxylene. When they're on opposite sides of the benzene, this is para-xylene or P-xylene. xylene. So ortho, side by side, meta, one carbon in between, para, two carbons in between, they're on opposite sides. I like to think of like meta, the M is for in the middle, right? It's kind of midway. They can be either side by side or all the way up across from each other, and meta's in the middle. So we have to know O, M, and P, ortho, meta, para. All right, so this first one here, I've got two bromines. Is there? So there's two bromines. So that'd be dibromo, benzene. Are those bromines ortho, meta, or para from each other? Meta. So this is M dibromobenzene. So what are the groups on my benzene for the second one? Nitro and ethyl. So it'll be ethyl, nitro, benzene. Are these ortho, meta, or para? Ortho. This is ortho, ethyl, nitrobenzene.
The question was, could the last one be nitroethylbenzene? Why or why not?
No, so you're still listing all your constituents in alphabetical order, just like any other naming thing. So always list them in alphabetical order. So that part of your naming rules doesn't go away. These are just a hodgepodge of like stuff from 150 years ago and more recent stuff. It's just like, yeah, whatever. So what's the last one? Hmm? Yep. P bromo propyl benzene.
The question was, we don't have to write out ortho, meta, or para on the exams or homework, correct?
Correct. I don't even think the homework makes you do it. Right? I think it's just all like if you're typing it, it's supposed to be italicized, but I don't have that setting. So before you ask, I'm not going to give you two substituents that give the common name. I'm only ever going to give you one. So you don't have to like worry about like which one takes priority or something. So when I was an undergrad, so if you think my books are bad, when I was an undergrad, I took was it advanced electricity and magnetism, some like junior level calc class, and the professor had his notes, and he would come in, and on the first day of class, he would make a mistake on the board, and he'd write like, "Oh, I guess that's a Chaco," instead of a typo. And apparently, a friend of mine failed that class and retook it the next year, and he made the exact same joke in the exact same spot because it was actually written into his notes. He wrote the Chaco joke into his notes, so he would do it every single year. So like I go back to the well, but I'm not like at the Chaco level of joke. I don't think like those are pretty rough. And my brothers I was in grad school. They're 8 years younger than me, so I was in grad school. They get to college, and I think they're taking Calc 2, and their Calc professor comes in, and no matter how bad any of your professors are here with technology, they're not this guy. He had a tape player, and he walked in, he sat down, and he hit play. Hello, welcome to the math zone. When you hear boop, turn the page. And he just sat in class in silence and played a tape that he recorded of himself when tapes were still a thing. And just played a tape. My brother's like, I gotta drop this class. I gotta find another section. I was like, yeah, you do, dude. So I've never just come into class and just been like, let me hit this YouTube video and just sit here in silence. I could. I'm getting to the point where I could. Yeah, man. All right. So, top left, we have to identify the two groups on the benzene, right? And figure out, do either of these groups give the benzene a common name? So I've got a methoxy and an ethyl. Ethyl doesn't give a common name, but methoxy does. So when you have a group that gives a common name, the last name of your molecule becomes that common name. So, and we're just looking at this, no ethyl group on it. What's that called? Anisole. And then that anisole has an ethyl on it. So this is ethyl anisole. And then you have to say, are those two groups on the benzene ortho, meta, or para? Meta. So this is meta-ethyl anisole. The name anisole takes into account the benzene plus the methoxy. So when you have the common name, one of your substituents is already rolled into your common name. So you don't have to like put it, say methoxy again, because it's understood with anisole. So for the next one, what is the common name that the next one gets? Styrene. So that is, because I put it in the exact same spot, that is right here is the styrene. Oops. And then I have the bromine, so it's bromostyrene. And then ortho, meta, or para? Ortho. What's the next one? P chlorotoluene. Right, and having the methyl group is what gives you the toluene. Last one. P cyclopent. Right, if it wasn't a cyclo and it was just 5 carbons in a straight line, what would that be? It'd be pentyl, right? YL. Just because it's a ring doesn't change that. Whenever just a simple carbon chain is a substituent, it's just YL. So it's cyclopentyl and then benzoic acid. So whenever you have just two groups on your benzene, you're using ortho, meta, and para to tell you where those groups are relative to each other. So far, so good? Other than the fact that I'm making you stuff 8 new names in your head, it's fine. What's up?
The question was, where is the space in the last name that you gave us, cyclopentyl benzoic acid?
There's a space between benzoic and acid, but the rest of it runs together. If, again, if you're writing the names like on an exam, I've got bigger fish to fry like other than like how big your space is in between things. But again, your exam multiple choice. So, and I'm not going to be like this one doesn't have a space and this one does. Which one's right? Like that. No, I got other things I can do. Right. So there is everything runs together in benzoic space acid. All right. So we're good on mono substituted and di substituted. So now let's go tri substituted. All right. So we go back to using numbers when we have tri substituted benzenes and above. So we just had like, a weird phase with di substituted benzenes where we use letters. Now we're back to numbers again. Yeah, we'll caveat here. Mostly the same rules as cyclohexane. So basically, if you can name a cyclohexane, you can name a benzene. Much like if you can dodge a wrench, you can dodge a ball, same thing. Right? If you can do cyclohexane, you can do benzene. Right? So again, if we don't have one of the substituents that gives us the common name, our last name is benzene. Going to list your substituents in alphabetical order. We're going to pretend like everything fits. All right, and you're going to number to give the lowest possible number in your name, right? Because it's a ring, the lowest possible number is 1, right? So no matter where I start, my low number is going to be 1, right? So now I have to look at the second number, right? So I can go 1, 2, or I can go 1, 2, so that's tied, right? So now I've got to look at the third number. If I go in the red direction, if I go clockwise, I get 1, 2, 4. If I go green counterclockwise, I get 1, 2, 5. 4 is less than 5, so I'm going to number in the red direction. So I'm going to get 1 ethyl, 2 bromo, 3 purple, 4 purple. Dang it, counting's so hard. I didn't use my fingers and my toes. Yeah, that's a one hand thing. I could even lost a finger in a freak like lawnmower accident. If someone able to do that one. Well, I was so watching the Super Bowl last night. I just couldn't help but I had to tell my wife, like, I said, Jason Pierre-Paul is missing a finger because he held fireworks and blew off part of his hand. I was like, yeah, cool thing. And then the next season they just put a big cast on his hand and he just played with a club for the whole year. Couldn't possibly take a year off to heal up his hand. No. No, it's just club people with a cast. All right. I gotta come up with something there. Gonna default to bromine, whatever. How have we spent 40 minutes on this? Dear gosh. We will get through these slides by the exam. All right. What would the top one be? Zoom coming in hot with the numbers and everything, right? No matter how you number, right? The numbers are always going to be 1, 3, 5, right? So there's a tie any way you start, any way you number. So then you're going to number to give the thing that comes alphabetically the lowest number, and it just works out that the thing that comes next alphabetically you get the next lowest number, so on and so forth.
The question was, what is that thing in the middle of the name that looks like 1,000?
That's fine. That's fine. Iota. What is that thing in the middle that looks like 1,000? Just hurt. Just hurt. We've been together for like 18, 19 weeks at this point. You should know. You should know this is awful handwriting, and you should have figured it out by now. But no, that's all right. You just want to stab me. Yes, ma'am.
The question was, how do you know where the double bonds go in the ring relative to where the functional groups and substituents are?
Doesn't matter. So, so the question is how do you know where the double bonds go? And I'm like, I haven't gone over this yet, but I'll show you like super quick, right? Because all the double bonds, we'll go back to that one named in a second. Because all the double bonds are conjugated with each other, they move, right? So they can be here or here. In actuality, there's a story that goes with this. What ends up happening is they kind of make this like just ring of electrons. So the double bonds are no longer like clearly defined in the actual molecule. So I've been trying to draw them the same, but I know I don't always. So it doesn't matter. It's still at its core, it's still benzene. Whether the double bonds are like this or like this, it's still the same molecule because in actuality, the double bonds aren't any of those places. They're all the places all at once, right? I like to draw them with the double bonds because later on we're going to do reactions. And I like you to have the double bonds there so you can like use them in mechanisms and stuff as opposed to the weird circle thing. I'm like anti-circle thing. It is 100% right and gets used. But in terms of like when you do reactions and stuff, you want to have your double bonds there so you can move electrons and know where positive charges to go and stuff like that. But yeah, so if I've drawn it, this way every time and I draw it like another way, they're the same. All right. So what about this last one here? I like it. So 1 bromo, 2, 3 diethyl benzene. That seems pretty straightforward. Now, what about when we have the common names? When you have a substituent that gives a common name, you start numbering from that substituent, right? The common name. Okay. So the substituent that gives the common name gets to be number 1. So you're going to always start numbering from that substituent and then decide which direction to go to give the next substituent the lowest possible number. I also end up using a lot of ethyls because it's the shortest carbon chain that I can get that doesn't give a common name. But, they could be propyl or butyl or whatever. So, first thing is we identify that we have a methyl group. So we know that that's going to make this toluene. And then we have the substituents off of that. So it's going to be chloro, ethyl, nitro. And we know since the methyl group gives us our common name of toluene, we start numbering, that's number 1. And then we number from there. So we know if the methyl is 1, it's going to be 1 chloro. Sorry again, 2 chloro. So confident when he said it too. 2 chloro, 3 nitro, 4 ethyl.
Do I need to put the number 1 in front of the toluene to denote where the methyl group is?
I don't have to put a 1. Because just like when you have like cyclohexanol, right? You know that, 2-methylcyclohexanol, you know that it's understood that the alcohol is at 1 because it's the thing that gives you the suffix. I don't have to put the 1 for the toluene because the rule is wherever the methyl group is that gave me that common name, that toluene, that's 1. And then I number for there, so it's understood. So what's our common name? Aniline. So that's going to give us our common name. That's aniline. Ethyl. Iodo. Isopropyl. Again, we'll pretend all that lined up. Great, so we know, again, that the carbon that has a nitrogen on it, that has to be 1. So then that makes ethyl 2. Great, 2, 3, 6. I gotta get one more in here. This is an important one. So what would that be? Mm-hmm. 2,4,6 trinitro toluene. That's TNT. Oh, duh. Like, yeah, you just have that, like, rattling around in your head. Like, oh, yeah, I've done that structure in my head since I watched Wile E. Coyote blow up the Roadrunner with it, or himself. Like, I've totally known what that is. Yeah. Duh. Everyone knows that. It's baby chemistry. I know that. All right. I think we're good. We'll do benzene as substituent, benzyl groups, and then we'll work through, like, why benzene is so stable.